Hey everybody, this is Mr. Ainsworth, and we're going to get into the Unit 1 review for Algebra 1 with me. And I'm Mr. Ainsworth here, and we're going to get into it. So do yourself a favor. Remember, this is a video. So remember, you can pause and play anytime you like. It's always a good idea when you don't understand something. So go back through it, rewind it. It's just a WMV file. So to rewind it at the bottom of the screen, listen to it as many times as it takes, work it. All right, make notes of the key points in red. Get a red pen, in fact, out and ready here because I annotate in red. And listen to it as many times as it takes. Go through the whole entire video to prepare for your exam on the Unit 1 in Algebra 1 and do your best, okay? Here we go. Okay, let's take each one of these inequalities and solve and graph. Okay, we want to do two things. We want to solve them, right? And we want to graph them. We want to graph the result. So here we go. We're going to take 17 plus n is greater than 17. We're going to step it out. Now I know that the variable here, n, is being added to 17. And in algebra, we always do the inverse. And the inverse of adding 17 is subtracting 17. Or you can say adding the opposite if you like. Okay. And so we have, we're going to add 17. So what do we have here? So we have 17 plus a negative 17 comes us out to 0. That's a 0 right there. Well, this is 0 too, right? So we have n is greater than 0. That means any number can be a solution if it's greater than 0. So 0 is not a solution. So n cannot be 0, okay? That's why it's open. Check this out. It's open at 0. Open means that n cannot be a solution. Keep that in mind. Excuse me, 0 cannot be a solution. Okay, only numbers greater than 0 can be a solution, like 1, 2, this one, 1.5, 2, 2.5, 3, 3, 3 1/3. Okay, all these numbers to the right. Any number greater than 0 can be a solution. So this right here represents all numbers, not x, let me change that, n, which could be solutions to this initial inequality right here. On number 2, we're trying to solve for p, not n, okay? The variables can change. So p divided by 2 is greater than or equal to 4. Well, we know that the inverse of division is multiplication, right? So we're going to multiply by 2 on both sides, okay? Now 2p divided by 2, well, the 2's cancel to 1, right? 2 divided by 2 is usually 1, especially on Sundays. Let me see, is it Sunday? Yeah, it is. Okay, so just a little funny there. And then 1 times p is p. So p is greater than or equal to 8, right? 4 times 2 is 8, usually, okay, for the most part. So any number greater than or equal to 8 is a solution. So since 8 is a solution, all right, we're going to go closed, all right? Closed right here. Why? Because 8's a solution. 8's greater than or equal to 8, right? Not only that, 8 divided by 2 is 4. 4 is greater than or equal to 4. It's a solution. 9 even works. 9 divided by 2 is 4.5. 4.5 is greater than or equal to 4 too. So any number to the right of 8, or any number greater than or equal to 8, is a solution. All right, so you got to keep in mind the difference between open circles and closed circles and what it means. Any number p could be to the right of 8, including 8. Okay, 8's a solution here. We're back in number 1. Well, 0 is not a solution, so we want open. So there's a big difference between open and closed on the graph. Keep that in mind. Now on this one down here, you got negative 13 times a. A is another variable, greater than or equal to negative 13. Well, let's go ahead and do the inverse. Now, what's the inverse? Okay, so let's take a look at this. Negative 13a means negative 13 times a. Now, the inverse of multiplication there is division. So we're going to divide by, well, the coefficient. The coefficient's negative 13. So if you divide by negative 13 on both sides, negative 13 divided by itself, well, that's 1. 1 times a is a. And remember, when you divide by a negative, you got to switch the inequality. Let's write that down. When dividing by a negative, all right, number, switch the inequality. And you should definitely write this down. In fact, you should highlight it because this is the most common mistake people make. All right, the solution is not a is greater than positive 1. Negative 13 divided by negative 13 is 1. No, it's less than or equal to 1. You got to switch the inequality from greater than equal to less than equal to. All right, so when we graph this solution here, 1's a solution because it could be equal to 1. So we're going to go closed at 1. All right, and then all numbers less than or equal to 1 lie to the left. All lesser numbers to the left, and all greater numbers to the right. And let's pick one, like 0. Negative 13 times 0 is 0. 0 is greater than any negative number, so it works. If I picked a number like 2, 2 wouldn't work. Negative 13 times 2 is negative 26, and negative 26 is not greater than or equal to negative 13 because it lies way to the left. Okay, so that'd be false. All right, so we can actually look at the number line and test the numbers to see if it makes sense, which you should do, by the way. Okay, number 4. All right, let's take a look at number 4. Yeah, negative 32 is less than or equal to negative 18 minus m. All right, I'm trying to solve for m here, and let me see. I'm going to look at the 18. It's not 18, it's negative 18, so I'm going to add the opposite first. I always add the opposite first before I do any multiplication or division. All right, so here I got a negative 32 plus 18. Well, I know the answer is negative because I'm more negative. And I know that 14 and 18 is 32. So I know this is negative 14 because 32 minus 18 is 14. When the signs are different, you got to subtract the numbers to get the result here, ignoring the negative sign temporarily. Okay, so you get negative 14 is less than or equal to, this is 0 right here, negative 18 and 18 is 0, is equal to, well, negative m, right? You got to pay attention to what's happening here. It's being subtracted, so it's actually a negative number. Now watch this. The coefficient is negative 1 right now. I'm trying to solve for m, and I know the coefficient is negative 1. Notice how I just inserted the 1 in there. It's a negative 1. So I want to divide by negative 1. But like I said over here, when you divide by a negative, you got to switch the inequality. So I get negative 14 divided by negative 14 is positive 1. I got to switch the inequality right here. Look at here. Boom. Right there to there. So from less than or equal to greater than or equal to, pay attention, all right, is greater than or equal to m. Obviously, those negatives cancel. These cancel too. So if 1 is greater than or equal to m, that means that m is less than or equal to 1. Oh, not 1. I meant 14. Sorry. 14 divided by 1 is 14. I just didn't write the 4 there. I was wondering what was going on here. So let me repeat this. Let me repeat it correctly here. So if 14 is greater than or equal to m, that means m is less than or equal to 14. This makes more sense. All right, so 14 is a solution. So m equals 14. It's a solution right here. So we're going to go closed here. All right, and all numbers less than or equal to 14 are like 13, 12. I mean, all of these numbers, right? So you have to graph to the left. They would only make sense. Okay. Moving on. Okay, so now on the second group, we got these compound inequalities right here. Look at it. Compound meaning more than one. More than one. All right, that's what compound means. So let's take the inequality down here. Let's take negative 69 is less than 7b minus 6 is less than 22. And let's work with it here. And remember, you have to understand that these inequalities have, well, they have a left in the middle and a right on the inequality. So keep that in mind. So whatever you do to one of the parts of the inequality, you do to all of them, okay? And I usually always add the opposite first. So if I'm trying to isolate b right here, b is right here, it's being multiplied by 7 and subtracting 6. So I'm going to add the opposite of the minus 6, all three parts. Notice that. So what we have is negative 69 plus 6, which is negative 63, is less than 7 times b. These cancel out to 0. 22 and 6 is 28. Now, I'm not done solving for b yet because it's being multiplied by 7. And I said multiplied by 7 because that's important, right? You always do the inverse, which is division. So the inverse of multiplying by 7 is dividing by 7. So you do it to all three parts. And you get negative 63 divided by 7, which is negative 9, is less than, well, 1b or b, which is less than 4. Okay, now from this point right here, this is all numbers between, the way you interpret this is all numbers. This is all numbers. Let me write that better. All numbers, all right, between negative 4 and 9. Between, excuse me, negative 9 and 4. Negative 9 and 4. They don't include negative 9 and 4 because there's no equal signs on here. All right, so what you do is you find negative 9 on the number line. There's right here, open. 4 on the number line is right here, open. Doesn't include, right? Because this is all numbers between, not including negative 9 and 4. And so you want x can be any number between them, so you go ahead and graph that, all right? X can be, or not x, but b can be any number here. Any number in this region here. So like negative 2 is a solution, negative 1, 0, 1, 2. All these numbers work. Let's pick one. Let's pick 1. 7 times 1 is 7, minus 6 is 1, and 1 is between these values. All right, any number greater than 4 or less than negative 9, they don't work. Okay? That's how you interpret it. All numbers between negative 9 and 4. And between means it doesn't include them, and that's why it's open here. Open here and open here, meaning that negative 9 and 4 are not solutions. All right, negative 9 and 4 are not solutions. Got to understand that. That's what between means. Okay, now this one's totally different. So we have 8 plus 10x is greater than or equal to 28, or, right, 2x plus 8 is less than or equal to negative 4. You got to solve these independently, which means separately, and then graph them both. All right, x can be either satisfy this equation or the second one. All right, not both, but or, either one or the other one. So let's add the opposite first. All right, and you get these cancel, and you get 10x is greater than or equal to 20. 28 minus 8 is 20. Divide by 10, because you always do the inverse. X is greater than or equal to 2. Or, well, what's over here? Let's add the opposite again. And you get 2x is less than or equal to negative 12. A negative plus a negative is a bigger negative. Okay, divide by 2. And the x is less than or equal to negative 6. Now, I didn't change the inequality here. I didn't switch it because I divided by a positive and not a negative. Keep that in mind. All right, only when you divide by negative do you switch the inequality. All right, let's graph these. All numbers greater than 2, okay, greater than 2 lie here. This is all numbers greater than 2. And all numbers less than or equal to negative 6. It's right here. Oh, less than or equal to. So negative 6 and 2 are solutions. Or excuse me, yeah, I said negative 6 and 2. So negative 6, that's a negative 6, guys. All right, and 2 are solutions. All right, that's why it's closed there. All right, closed. Okay, so x could be here and x can be here, not in between, okay? 0 is not a solution. 0 is not greater than or equal to 2, guys. All right, it's less than or equal to 6, but it's not greater than, well, excuse me, 0 is not greater than 2 either. All right, 0 is not greater than or equal to 2, and it's not less than or equal to 6. So any number in here, these are not solutions here. Okay, these, let me put that down. These are not solutions here. All right, okay. Moving on. Moving on. Okay, here we go. If it's a, hey guys, remember it's a video. Okay, let me say this one more time. So if you need to rewind it and listen to it again because I talked too fast, well then pause the video right now and rewind it. Don't go on if you don't understand. Listen to it again and again. All right, it's a video. Got to pause and play. Okay. Let's take this one. 2m plus 7 is less than or equal to 23. And okay, this is a whole lot different now. All right, different situation. And 9m plus 5 is greater than or equal to 50. Well, let's do what I did on the previous ones. Let's add the opposite first. I always do that every single time. All right, I get 2m is less than or equal to 16. 27 minus 3 is usually 16. And then divide by 2. All right, well, what do you get? M is less than or equal to 8. Over here, I'm going to add the opposite, just like I did on the previous one. Same thing. If I see a plus 5, I go minus 5. I mean, it's always the inverse, guys. It's that simple. Algebra is the same every single time. 50 minus 5, 45. 9 times 5 is 45. So, or you can divide by 9 if you want. All right. So 9 is greater than or equal to, all right, 5. This is an and case. I'm going to highlight it. You got to satisfy both. You got to be less than or equal to 8 and greater than or equal to 5. So I'll tell you what, greater than or equal to 8 is over here, excuse me, less than or equal to 8 is this way. All right, greater than or equal to 5 is this way. All right, where's the solution? Well, in between, right? You got and including 5 and 8. So here's the solution in blue. All right, m could be any number between -5 or 5 and 8, including 5 and 8. So m equals any number, all right, between 5 and 8, including 5 and 8. All right, if you're bigger than 5 and less than 8, or bigger or equal to than 5 and less than or equal to 8, then you could be any number in there. So you can be 6, you can be 7, you can be 7.5, you could be 5.5. All right, the keyword is between. So keep that in mind. All right, that's what it means. So blue is the solution, not the ones in red here in the graph, guys. Blue, the one in blue is. Keep that in mind. All right, on the last one here, so 12 is less than or equal to 6 plus 6r is less than or equal to 60. Once again, you got 3 parts to the inequality here, a left, a middle, and a right. And I always add the opposite. So if I see a positive 6 added to the variable term, I do the inverse, right? So we have 6 less than or equal to 6r less than or equal to 54. All right. At this point, it's 6 times r, right? The inverse of multiplying is dividing. So we divide 6 by 6 to get 1. That's less than or equal to 1r, which is r. This is an r right here. Is less than or equal to 9. 54 divided by 6 is usually 9. So this is any number between 1 and 9, including 1 and 9. So any number, all right, between 1 and 9, including 1 and 9. Or we say inclusively, okay? Including 1 and 9. So what we do is we graph that. So here's 1, here's 9, and any number in between there. Okay? Notice that r is between 1 and 9 even in the inequality. I mean, it kind of makes sense, just even visually. Okay. Okay, now in this one, we got to solve for x here in the equation here. And the first thing I do is, well, I'm going to distribute twice. Okay, I see a distributive property here. So 6x minus 13 is equal to negative 20. All right, negative 5 times negative x is a positive 5x. Pay attention right there. It's positive. A negative times a negative is a positive. Most common mistake people make right is right there. They put down a minus 5x, and that'll produce the wrong answer. So be careful there. All right, I'm going to collect like terms. All right, collect like terms. So I'm going to add the opposite of both sides. I get x minus 13 is equal to negative 20. These cancel right here. 6x minus 5x is x. Minus 13 equals negative 20. Add the opposite again. And you get x is equal to, let me see, a negative 20 plus 13. Well, that's a negative 7. All right, so x equals negative 7. Same thing over here. You want to distribute a couple times. Okay, so let's do that. Negative 8x plus 28 is equal to 4x minus 8. Why? Because 4 times 2 is usually 8, right? So this portion here is this portion here. 4 times x, 4 times 2 with a minus sign in between because you're subtracting the two terms. I want to collect like terms, so I'm going to add the opposite here. So I'm going to add a negative 4x here, and I'm going to add a negative 4x here, or you can think of as minusing. A negative plus a negative is a bigger negative, so I get negative 12x plus 28 is equal to negative 8. Again, bring down the minus sign. Add the opposite again. Oops, I'm sorry. That was not correct. Add the opposite. Opposite of a positive 28 is a negative 28. Be careful there. So we get negative 12x is equal to a negative plus a negative is bigger negative. You take a negative here and negative here. Oops, negative here. You get a big negative here. Okay, that's a negative 36. So at this point, you want to divide by negative 12 because you always divide by the coefficient here when the inverse of multiplying is dividing. It's negative 12 times x there, so I divide by negative 12. These cancel, and I get x is equal to, there's a big arrow right here, negative 36 divided by negative 12 is positive 3. Okay, now on the literal equations, okay? Literal equations. So we want to solve for these particular variables here. All right, I'm just going to highlight them so you know what I'm doing. So in this equation that they give us here, we're gonna take it and we're gonna solve for that particular variable. And that variable is right here. So the very first thing we do is we cancel out the c. C is positive, so I'm going to add the opposite. There we go. Opposite of c is negative c. So these cancel, and I get negative a is equal to d plus r minus c. D plus r minus c. Now, that's the only way I can write it because, d, r, and c are unlike terms. They're different variables. Okay? And on this one, I divide by the coefficient, which is negative 1. So I divide them all by negative 1. And it switches all the terms. It switches the signs. So switch signs of all three terms. D divided by negative 1 is negative d. R divided by negative 1 is negative r. Negative c divided by negative 1 is positive c. And there we go. So when you divide by negative 1, it just switches all the signs from positive to negative and negative to positive. That's all it does. All right, look at that. Positive to negative, positive to negative, negative to positive. That's all it does. Just switch all the signs. That's all you have to do. Easy. Okay. Now this one, okay, let's subtract b. Opposite of b is negative b, right? So you have u minus b is equal to a times k. I'm going to put a dot in there. Why? Because they're being multiplied. A lot of people see AK as like, they don't know what's going on between A and K. Well, it's being multiplied, right? And it's important to know that because what you're going to do is divide, because that's the inverse of multiplication. So you divide both sides by K. These cancel out to 1. K divided by K is 1. And you have A times 1, or A, is equal to U minus B divided by K. Or A is equal to U minus B divided by K. Same thing. You got to get used to always doing the inverse. Like on this one here, we got G is equal to A times C times B. So G is equal to A times C times B. And I say it like that because you have to know they're being multiplied. Why? Because you do the inverse. You divide by CB. C divided by C is 1. B divided by B is 1. And you get G divided by C times B is equal to A. It's that simple, guys. Believe it or not. Okay. Now this one's, a little bit more challenging. A lot of different ways you can solve for A here on this one. I'm going to bring A on the left, so I'm going to add the opposite here. I get A plus Z. A plus C right here. I go alphabetically. These cancel, right? Negative A plus A is 0 equals B minus M. And I'm trying to solve for A, so I subtract the Z. These cancel, and I get A is equal to B minus M minus the Z, because that's what I did. I subtracted Z, and I'm done. I solve for A. Okay, now in this one, I get U is equal to Y times K times, Y times X times K, and I need to solve for X, this one. So I do the inverse of multiplying. I divide both sides by YK. These cancel out to 1, these cancel out to 1, right? What K divided by K is 1. Any number divided by itself is 1. And I get U divided by YK is equal to X. Or you can say X is equal to U divided by YK. All right, Y times K. Now this one here, I'm trying to isolate X, okay, which is right here. I'm going to add Y. So I get Z plus Y is equal to X times M. I'm going to put a dot here because you need to know it's XM means X times M. So I divide by M. Why? Because M divided by M is 1. So I get X here is equal to z plus y divided by m. You're saying, hey, Ainsworth, it doesn't look like that. Well, you can write like this too. Z plus y divided by m equals x. But if that's the case, guys, you just switch the sides of the equation. It's the same thing. Okay? All right. Let's keep rocking. Absolute value equations. Okay? Absolute value. Feel like Arnold Schwarzenegger right there. All right, that's the absolute value right there. So, there are a couple different ways you can approach it. Okay? Now, I know that the absolute value of something is the distance from that number to 0. So, the absolute value, whatever this is 36 units away from 0. See, equals 36. So, I know whatever this quantity is, I'm going to highlight it. This 7n minus 1, I know it could be equal to 36 or negative 36. Because the absolute value of 36 is 36. The absolute value of negative 36 is 36. Because both of these numbers are 36 units away from 0. So I actually have to solve two equations here. I have to solve 7n minus 1 equals 36. And I also have to figure out 7n minus 1 equals negative 36. I have to solve both. All right, so let's do that. Okay, I'm going to add the opposite first. I get 7n minus 1 is equal to 37. I'm going to add the 1. I'm going to add the opposite again. So I get 7n equals 38. That's okay. And at this point, divide by 7, and I get n is equal to 37 eighths. Excuse me, 38 sevenths. 7 divides into 38. I don't know. Let me see. How about 5 times? 5 times 7, 35. 38 divided by 7, 5 times. 35, let's say. Remainder 3. So 3 sevenths, 5 and 3 sevenths. Or over here, we can have the opposite. So 7n is equal to negative 35 divided by 7, and I get n equals negative 35. So my two solutions are negative 35 and 5 and 3 sevenths. Okay, I have two solutions here. All right, so on this one here, what I'm thinking here is, whatever this is, let me highlight again, the 9 plus b, whatever it may be, it's either equal to 13 or negative 13, because I know that the absolute value of 13 is 13, and I know the absolute value of negative 13 is 13, because they're both 13 units away from 0. So once again, I have to take this quantity in here, whatever it is, and set it equal to the two possibilities, 13 or negative 13. Okay, add the opposite, and I get b is equal to 4. Add the opposite, and I get b is equal to negative 22. So you have two solutions here, 4 and negative 22. There are two solutions. All right, part 2. Holy cow, man. This is a video here, guys, so I know this is long, but hey, this is a review for your test, right? So you can always rewind it, come back to it later. I know it's long, you're working hard, but it's a pause and play thing, right? So you can pause and play, come back to it if you want to, take a break, come back to it, but work hard, right? Make yourself proud, get through it, the whole thing. All right, here's part 2. So you're going to substitute the values. You got to evaluate given the values here. We know p is negative 2 and q is 1, and we need to evaluate this crazy expression here, which is p times a quantity, p divided by 2 minus q. So the first thing you do is you substitute values in. Sub values, all right, into expression. All right, so here we go. So it's p, which is negative 2. So you have negative 2 times negative 2 divided by 2 minus q, which is 1. So I substitute, then evaluate. So this is equal to negative 2 times, well, we got negative 2 divided by 2, which is negative 1, minus 1 more. This is negative 2 divided by, or excuse me, times negative 2. Usually negative 1 minus 1 more is negative 2. And that's going to be equal to positive 4, right? There's my end result right there, positive 4. So when I take these here and substitute them in, sub values in, I get 4 out of the expression, okay? Now in this one here, q is -2, so q right here and p goes in here. So here we go. So q times p, so we get -2 times -4. So -2 times -4 minus q, which is -2, all divided by 2. So the very first thing is I substitute my values in, and then I use the order of operations. I know this portion right here is 8. All right, so let's get 8 here. Negative times a negative is a positive. And then right here I see a double negative. When you subtract a -2, you add 2. So right there, notice that this portion here is +2, right? Because when you subtract a -2, you add 2. And that's that entire result there is bin divided by 2. So I get 10 divided by 2, or 5. Okay? So you substitute in and you evaluate according to the order of operations. Like on this one here, I know it's a number cubed minus something times something, right? So, okay. So let's take this in. Let's substitute x in. It's -2. And it's x times z, so it's -2 times z. Z is -2. So notice how I substitute in, and notice how I use parentheses, okay? You have to use parentheses when you substitute a negative number in. Now this right here is -2 times -2 times -2 minus this right here, that's 4. So I'm just going to simplify that. Okay, and this right here is 4 times a -2, which is -8. But -8 minus 4, well, that's -12. So my end result is -12. And that's what evaluating expressions is all about. You use the order of operations here. All right. One more time. We got x times the quantity x plus y squared. So here we go. -4 times -4 times, excuse me, plus -1 to the second power. Notice the use of parentheses right here. When you substitute a negative number in for y, you gotta give it a hug, guys, all right? When you take a negative number to a power, you gotta give it a hug. You gotta use parentheses. All right, if you don't understand why, then see me in class. I'll show you. So this is equal to -4 times -4 plus 1. See this whole thing right here? This part is this part. -1 squared is 1. Now, on the inside, -4 plus 1 is -3. All right, you have to simplify here to here. It's got to be correct, right? -4 plus 1 is -3. -4 times -3 is +12, and there you go. All these expressions are equal. So we did a little bit of evaluating expressions there. Now let's get into what are called linear equations, okay? Joe's bike rents bikes for $14 plus. Ooh, plus. Okay, plus $6 per hour. Okay, Mofor. Oof, what kind of name is that? Paid $38 to rent the bike. All right, for how many hours did he rent the bike? Well, let's figure this out. Well, all right, so he paid 14 bucks. All right, plus $6 per hour. $6 per hour. Well, we don't know how many hours, so let x equal number of hours. So times, you always take the cost for the item, whatever it may be, times how many items you have, right? So if he had $6 per hour and he rented it for X hours, you got to multiply that. So 6 times X. And it says how many hours did he rent the bike? Well, I need to know how much he spent. Okay. So he paid total 38 bucks. This is the total. $38. This is the total. So you paid it $14 initially plus $6 per hour, where X stands for the number of hours. All right, and he paid 38 total. So we got to figure out how many hours he rent. So let's solve this. Okay, let's add the opposite. And we get 6x is equal to 38 minus 14 is 24. Since 6 times 4 is 24, x has to be 4. And since x is the number of hours, this is 4 hours. Okay. Now in this next situation here, let's suppose you bought a magazine for $7 here, and you had 3 candy bars, and you spent a total of $13. How many of each candy bar cost? Let me see. Okay, all right. So you bought a magazine for $7. Okay, so cool. So for the you got money for the magazine plus money for the candy bars. All right, and let me see. You spent a total of $13, and this is the total. Now you spent $7 for the magazine plus you got 3 candy bars, but you don't know how much it costs. But you bought 3 of them. So you're going to take 3 times the total cost of it, an individual cost, and that's going to be a total of 13. So here in this situation, X stands for the cost for per each candy bar. Okay, we don't know how much the candy bar costs. So let's solve it. Let's subtract 7. You get 3x is equal to 6. 13 minus 7 is 6. Since 3 times 2 is 6, each candy bar costs $2. All right, for each candy bar. And that's it. You know, back in my day, candy bars were like 25 cents, 35 cents. I mean, it was amazing. I bought candy bars, Snickers, and all those guys for like a quarter. And now, and that was back, I don't know, that was 30 years ago. But now in 2016, and this problem is $2 a piece. Give me a break, man. That's too much money. They need to decrease the price. Okay, so number 7. We rent a bike for $16 plus. All right, again, notice the key words here. So it's 16 plus something, right? So we rent a bike for 16 plus $3 per hour. So let's say that X equals the number of hours. If it's $3 per hour, you got to take 3 and multiply it by the number of hours to get the total amount of money that has been spent. And he paid Pranav, where's that come from? Paid $31 total. So $31 total. All right. So how many hours? How many hours did he rent the bike? Well, I don't know. Let's figure that out. So let's subtract 16. And you get 3x is equal to 15. Since 3 times 5 is 15, x better be 5 hours, right? So we rented the bike for 5 hours. This is rental time. Okay? Okay. Now the next one here, we got another renting situation. Rent a bike from Maria's Bikes. It costs $20 plus, here we go again. So 20 plus $7 per hour. So 7 times the number of hours, we'll call it x. X equals the number of hours. Okay? And he paid a total. This is a total amount of 48. So it equals $48 total. So $20 initially plus $7 per hour. So you always take the cost and multiply by the number of hours. And if you want to solve this, okay, let's go for it. You have 7x is equal to 28. 7 times 4 is 28, so x equals 4. For what, you might ask? 4 hours. Okay? And so, yeah, you're going to have to use your basic knowledge of linear functions to solve for unknowns. Okay, now let's get into part 3 here. We're halfway done. A little bit more than halfway because this part's short. Okay, little equations and working with units. Suppose distance equals rate times time. You saw this in middle school. Now, distance equals rate times time. D equals RT, the famous dirty equation, okay? You see this all the way back, even as back as 6th grade. But in middle school, we work with this a lot, and you see this a lot. If you're going down the street, not down the street, if you're with your parents in the car and you're traveling at 60 miles per hour, in 1 hour you travel 60 miles. In 2 hours, you travel 2 times 60 or 120 miles. It's the rate times the time. In that case, it's miles per hour times hours. In this case, let's read it. If rate equals meters per second, r equals rate, okay, rate is speed, t equals time in seconds, all right, then distance has what units? Well, let's figure this out. Let's take distance here and substitute in it's r times t. So it's rate, which is meters per second, times the time, which is in seconds, And if you multiply the two, you get meters times seconds divided by seconds. Anything divided by itself is 1. So you get meters. Distance equals meters. And that makes sense, okay? That's a unit of measurement in terms of distance, okay? Now, if we want to solve for r, d equals rate times time, you want to do the inverse. So you want to divide by t, all right? You might ask why. Well, the inverse of multiplying is dividing. You always do that. T divided by t is 1, and so distance divided by time is equal to the rate. Or you can say rate equals distance divided by time, however you want to do it. It's the same thing. Okay, if you want to solve for t, well, you take distance equals rate times time, and you want to divide by r, right? The other variable. So distance divided by the rate is equal to the time, or you can say time is equal to distance divided by the rate. And then the last question says, what are the units? All right, well, let's substitute them in. So t is equal to d divided by r, distance is in meters, rates in meters per second. Now, when you divide by a fraction, what you're supposed to do is multiply by the reciprocal. So let's write that down here. So here's the key. Okay, multiply by the reciprocal. Come on, I gotta spell it right. There we go. So that's division right there. So t is equal to m times the reciprocal of this fraction, which is seconds over minutes. You just invert it. And notice that meters divided by meters is 1, and you get seconds here. All right, time is in seconds. That should make sense. Okay, it's either in seconds, hours, days, weeks, years, and so on. Okay, so you got to substitute in units for your measure, or given your equation, and given the particular units of the situation. All right, last part 4, error analysis. Given an equation here, given this equation, all right, find all the errors? All of them. There may be more than one. Okay, there may be more than one. So keep that in mind. Okay. All right, so let's see here in step A, B, and C, we got steps. Well, you're supposed to distribute the number in through here. And I see that 1/3 has been multiplied by x. That's correct. So this part's correct. But this part right here, this part's not correct. There's the error. All right, you're supposed to take 1/3 times 6. So the error is that the 1/3 was not distributed twice. So 1/3 was not distributed twice. All right, there's the error. Okay, so let's continue on. On this next step here from A to B, I see that the person added 6, and they weren't supposed to. This is wrong too. There's an error here. This is an error. Okay, and this is an error. Well, 4 plus 6 is not an error, but what they did was an error. So when they should have errors, they should have subtracted 6. They should have added the opposite. They should have added the opposite. Okay, -6. So there's an error there. Let me see. There's also an error here. Dividing 1/3 by 1/3 is correct. Okay, given the incorrect equation here. Okay. However, from here to here, this is incorrect. Okay, so dividing by 1/3 is correct. This is good. All right, but this is not good. Okay, 10 divided by 1/3 is 10 times 3, which is 30. All right, so you don't divide by 3, you divide by 1/3, or, all right, multiply by the reciprocal, which is 3. All right, so there's a couple different errors involved here. So I tell you what, since we know what happened incorrectly, let's do it correctly here. All right, so let's do it. So here we go. We're going to distribute twice. So you get 1/3 times x plus 1/3 times 6 equals 4. Well, 1/3 of 6 is 2. 6 divided by 2, excuse me, 6 divided by 3 is 2. And so you should get 1/3 x plus 2 equals 4. The next correct step would be, so add the opposite. And you get 1/3 x is equal to 4 minus 2 is usually 2. And at this point, you got to multiply both sides by 3. And you get x is equal to 6. All right. 6 plus 6 is 12. 1/3 of 12 is 4. So we know. We can check by substitution. Okay? So you're going to have to do something like this. You're going to have to analyze someone's work and say, hey, where did it go wrong? And then you should know how to do it right. Okay, this is correct, which is the goal. Okay, you want to do it correct. All right, so again, this is a video here, guys, right? This is Mr. Ainsworth, and this is a video, and it's produced so that you can go at your own pace, and you can also do what I'm doing right now is you could go back and you can re-listen to anything you wish. All right, it's extensive for a purpose, so go back and work hard and redo the problems and practice. Repeat the same ones over and over again until they become easy. That's what we do on the sports field, but I don't see enough kids doing it in the classroom. So practice for repetition, practice for understanding, and give your best. Always give your best. And I'll see you on test day. This is Mr. Ainsworth signing off. Bye bye.